All right, so let's look at those ascending tracts that we talked about last video. And remember, they're the tracts that carry sensory information up the spinal cord from the periphery. And it turns out there's 3 neurons that are going to conduct this pathway. The first neuron, called the first order neuron, takes the information from the skin surface, let's say. You're detecting heat, you're detecting pain, you're detecting some sense function, and that information will travel up the axon and will synapse within the spinal cord most likely. Then a second order neuron will carry that information up the spinal cord into a region of the brain called the thalamus. And the thalamus is a region that receives almost all sensory information, filters it, figures out what's important. And then from the thalamus, the third neuron in this pathway will take the information to the region of the brain that happens to deal with that particular sensory function. Okay, so 3 order neurons here, 3 neuron pathways is very typical of all sensory pathways. You should know the first order pathway then is mostly peripheral with a little bit of central right at the end. And then the second order pathway is all central nervous system. And the third order pathway is all brain. Here are our 4 ascending tracts that we're going to review in this video. We have the posterior column tract, the spinothalamic tract, the spinoreticcular tract, and the spinocerebellar tract. And so you can see here we have a pathway. This is the primary, the first order neuron, conveying that information to where it synapses in the spinal cord. The second order neuron carries the sensory information to the thalamus, which then sends it to the part of the brain that's going to deal with that particular sensory information via this third order neuron. All right, so let's look at each of these individually. The posterior column is back here in that posterior white matter. All right, and we see that there are 2 portions of it. Don't worry too much about these 2 individual portions. But one portion is devoted to carrying information from the legs, and the other is devoted to carrying information from the trunk. What kind of information? Well, you can see here it's vibration, some pain information from your organs and such in those particular areas, and the deep touch and 2-point discrimination. What the heck is 2-point discrimination? Well, if I take a compass that has pointed ends and I touch my skin, I've got those 2 points right together. I can't detect that there are 2 points. The area that the neuron serves is too large for me to distinguish that there are 2 points. So I've got to separate it, keep widening out those 2 points, and eventually I'll reach a width where I can detect 2 points. And that's called the 2-point discrimination. So what it's a reflection of is how many axon branches are coming out of this one neuron going towards my skin, how many branches go out, and how big an area of the skin does that particular neuron detect? How much information, how much of an area does that neuron detect? And that's 2-point discrimination. So again, posterior column's all about the limbs, and also included is the trunk. So we're talking about this wide amount of white matter in the posterior portion of the spinal cord. The spinothalamic tract carries much information, but mostly what we want to focus on is pain and temperature. That's the major things that are going to be focused on with the spinothalamic tract. You can see it right in here. This is where that information will be conveyed up to the brain. Other things, tickle, itch, and so forth, are conveyed via the spinothalamic tract. The spinoreticcular tract has to do with pain, most certainly, and so the spinoreticcular tract is part of this, the other part of this system found in this region. You have the spinothalamic portion, and then a little or a much smaller spinoreticcular tract that's conveying just pain information. The spinocerebellar tracts, it will learn that the cerebellum has to do with position and movement and your 3D position in space. And the spinocerebellar tracts, these 2 together, will take information from the spine up to that region of the brain called the cerebellum. So these are going to carry these sensory signals that convey position. Proprioception, these receptors are found in your muscles and your joint regions and so forth. And so they're conveying that position information that's so vital, so you can ride a bike at the same time, talk at the same time, point your finger, whatever it may be. Now you may notice with these last three tracts, we had spinocerebellar, spino-reticular, spinothalamic. What's common among all these is they all begin with spino, and this is how they're named. They're named for where they begin at. And then the suffix will be the term for where they end up at. So this ends up in the region, the cerebellum. The reticular ends up in the region of the brainstem called the reticular formation, and this is going to end up in the thalamus. So you can see with these three tracts that they're named in a particular way, and we'll see this again when we talk about descending tracts. So to define proprioception, once again, it's non-visual sense of the position of the body. So the summary here is, of these four tracts, the spinothalamic carries touch but pain and temperature. Posterior column carries the 2-point discrimination information. In other words, very detailed information on touch and sensation, as well as deep pressure and vibration. Spinocerebellar carries proprioceptive information, and the spino-reticular is big time into pain. So you'll notice there are two pain pathways, and this is going to come about again when we discuss pain in a later chapter. There are two ways that it is handled. One is an emotional way, the other is a physical response to the pain.